Hello everyone and welcome again to our channel. In today's lecture we will study list in Prolog language. Well, list is widely used for non-numerical programming. If we say in general, Prolog is actually itself a non-numerical programming language. A list is a data structure using which we represent a collection of elements. Here we have, for example, this is an example of list that have elements like red, blue, green, pink and yellow. In Prolog, a list generally has two parts, head and a tail. The first element or item is called head, while the rest of the elements or items are tail of the list. In Prolog, to differentiate head from tail, we use a bar. Here you can see H, then we have bar and then T. So H represents head part and T is the tail of the list, while this bar make differences between them. From above example we can say red is the head of the list while other all items represent the tail of the list. The tail can itself be a list. Okay, now let's move towards programming part. Firstly we have to search for SWI Prolog, that is to start the number computer system. So here we have that console for Prolog. Okay, let's open up new file. Let's name as it for example searching item list dot pl. As I mentioned earlier that pl is the extension of Prolog language. How should open? Yeah, let's open now. Okay, now we will see how we can define a list in Prolog and how we can search an item in that list. So for identifying an item in the list, there is a built-in function named member. But that member take two arguments. The first one is a value that you want to search in the list, and here we represent we are using a variable so that we can take multiple values from console. And then the second part, that is a list represented by brackets. So first one is, in first case X will be searched as head of the list, so that's why we use X, and the head part also we used X, same variable. Then we have bar and then anonymous item underscore. Here this first argument or function has finished. Now we will move towards the second part. What in case if the variable is not represented or present at the head of the list, then what will happen? Then we will search it in the tail of the list. So in this case the anonymous item will come part of head. Well, anonymous means that here it will not search. This part will not be searched during this execution of this function. Then we have bar and then we have tail. Let's represent it as T. Then we have second part of this rule, member X T. So here we see that we can write this built-in function member in two different ways. For finding out the item in head, we use the first line or first fact, and to search in tail we use the second one. This member is a recursive function. If we click on it, you can see down there it says that it is a recursive call. So it means every time when this one is executed, and if they don't find the item on head, it will move towards tail. Then this tail will provide the rest of the items back to the first argument. Which means if there was 1, 2, 3, 4, 5, 3, 5, 4, 5 for example, and we want to search value 5, so first time head will be 1, and the rest 2, 3, 4 will be tail items. But after execution of second function, this upper argument will be called through here, and here we will have the remaining tail, and then from this tail again the first element will be taken as head and compared with this item that we want to search, and this way it will continue until we don't find the required member. Now we save this one, and now we will go towards console. Okay, now as I mentioned before in videos that we need to give path or address of the Prolog program. We can simply do it through console, and here we can choose what was the name of this search list. This one. Now let's write the function member to parentheses. Let's write first element maybe let's say 4. The second argument will be that list 4, 5, 7, 8, 10, and full stop. Let's see, is 4 a member of that list or not? When its value is missing. Okay, let's see what will be the result. True. Okay, let's try it again. Now we just remove 4 from here. No, what does it say now? False.